Hi, my name's Steve Bradshaw, and I wanted to know what all the fuss was about NVMe's, particularly when it came to IBM. Now, I realize we're online, and Generation TikTok says that I have to get this out quickly. So, a summary version for those of you who are younger and have short attention spans. What are NVMe's? They're a place where you can put your stuff. Why should you care? You'll find your stuff faster. What do they cost? A lot less, so you can afford more stuff. Have I made it clear yet? Okay, well, if you need more detail than that, I need a disclaimer. Those of you who are used to seeing IBM presentations, you'll see disclaimers that look like that. Have you read it all? Have you got your legal department to agree it? Well, I'm a little bit of a simpler guy than that. This is my disclaimer. I have tried ever so hard to make sure that everything you're about to see is correct. Right? But opinions are like buttocks, we've all got them, and you're about to listen to mine. Not Roden's, not the IUG's, and certainly not IBM's. My opinions may not be right, but then again, maybe yours aren't either. But shortly, please don't sue me if you don't agree with me. So, what is this all about? The following presentation was given at the IUG just a few days ago in Wolverhampton, and we discussed what are NVMe's and why should we care and what do they cost. If I go with the executive summary, just to see if I can get a pitch to see if you're in the right place, well, NVMe's are the next generation of storage, and they can read your data 12 times faster than the traditional storage you're using today. What do they cost? Well, there's a substantial saving. I did some costing based on IBM list prices, and the P05 entry-level Power 9 server was 30% cheaper, not the storage, the entire price of the hardware when using NVMe's. And if you went to a slightly larger P10, the second tier up, I got that to a staggering 46% saving based on RRP. The following presentation, we're going to pick up from here, and it all started with a slide from Douglas Gibbs. I hope you enjoy it.
Is the next one. We'll put fiber on one side for a moment because even that tends to go through SAS at some point. So SAS is, just think of it as a type of highway. It's got a theoretical maximum read speed of 420. Now, don't worry about what that is. Whereas NVMe has got a theoretical maximum read speed of 1,400. So it's like 3 times, 2.5 times improvement there. And the write speed, it's 50 versus 250. So even allowing for not going at the maximum speed and not being the most efficient and other things on the bus, is there really, I'm going to say, a 3 or a 5 times improvement in storage? And when I mention this SAS thing, by the way, that's the speed that an SSD can go at, right? Not just a HDD. SAS is the bus that we talked through, not the speed of the adapter behind it. So there's a whole quantum shift. I thought, really? Are they going to be that much faster? Potentially 5 times faster because they've opened the speed up. So I wanted to know what difference that would make to IBM I, because this applies to all computer systems out there in the world, even smart phones and devices. Yeah, we've all pretty much settled on flash, but it's how you get at that flash and non-volatile memory. So I did what anyone would do. I Googled it, and in 0.57 of a second, I got 4,380,000 possible answers. None of them were any help. So particularly not when it comes to IBM I and real life experiences. So I thought, okay, I looked in the corner and there were 2 spare Power 9s not doing very much. Yeah, we've all got them. But there they are. So I thought, I'd like to introduce you to my spare Power 9s. That's Alison and Scott, okay? If those of you who haven't guessed yet, Alison is strong enough to manage any workload, no matter how inefficient, and Scott's a stand-up guy. There's a group of you out there who know what I'm talking about, missing you too. So these are my dynamic P9 duo. I never thought I'd be able to say P9 without getting told off by my mother, but she's not here, so hi, Mum. So bugger it, I thought. I better test it myself since no one else is going to tell me the answers. I mean, I know IBM knows the answers, but there's a lot of variability in here as to how these things are measured. So they don't tend to go public. I thought, I'm going to take a typical workload and try it myself. So what am I going to do? I built a test environment and I used Alison and Scott. Alison got the traditional storage in it and Scott's got the new NVMe. Fine, they're both Power 9s. So based on typical hardware, these are low-end scale-out Power 9 servers. I can't afford spare ones that are at the enterprise level. Okay, I used a typical IBM I workload, and we don't tend to use a lot of cores. We're very efficient. Yeah, we like fast disk. Yeah, we like fast RAM, but processor wise, actually, we're pretty lean. So a single core Power 9, 64 gig of RAM, LTO7. I'm looking around, I can see a couple of business partners in the room. Would you say that's a very common type of system out there if you were flogging them? Yeah, fine. Okay. And so I thought, I've got to use IBM i7.4. There's no point in testing it with anything older than that, because who would do anything other than use the current version? Small user environment, so it's got 1.4 terabytes of storage. Okay, 70% full. That's what most of our boxes tend to be when I get there, no matter how lean they are when they start. They're like kids. Imagine you have a swing bin in your kitchen and you have children in the house. That bin is always full. You could put a second swing bin next to it. They would both be full. It's not like one would get emptied at any one time. So I used exactly the same LPAR configuration, the same system values, the same users, right? I based it on 0.2 of a terabyte of normal library objects and 0.8 of a terabyte of IFS objects. There's about 4.7 million of those. The only difference in any of these tests was the storage or how the storage was configured. Same operating system, same software, same processes. I wanted to know what difference the storage would make. Is it really going to give me this 3 times better here or 5 times better there that this bus architecture said it could? Really quite curious. So what combinations of storage did I test? Well, again, I think the most common one with NVMe's, and we'll come back to what they are in a minute, right? But just they are faster disks, or they are disks. Let's see if they're faster. I used a pair of them, which yielded 10 disks mirrored. I could have got more disks, but I just wanted to have like for like, okay? So I created, using NVMe, 10 times 200 gig disks. That's with a pair of them, so it's 5 on each one, and I mirrored them. Nothing new there. We've been doing mirroring. Well, I had a fringe when that started. It's just been forever. I also wanted to test software-based mirroring, so exactly the same on our traditional spinning disks. So the most common disks that get sold are relatively small, the 283 SAS 15K high-speed SAS disks. Brilliant. And we use relatively small ones so we can have lots of them for performance. We've, forever we've been told you've got to keep that ARM count up. If you want performance, you've got to have a lot of ARMs. To a degree, that's still true. More on that later. So software mirroring, very common way of doing that. So there again, there are 10 disks inside the machine, and they are mirrored 5 and 5. And it then yields out, in this case, 10 times 283. Okay. And then I did hardware RAID 6. So this is probably the most common configuration I see go out there now because it yields good amount of storage. So again, that's that small box. It's got 10 disks in it. It's got the high-speed RAID adapters in there that we started getting from Power 8 and we have now in Power 9. Okay, with a good 8 gig of cache, and we use RAID 6 because then we can afford to lose one disk, machine still runs. We lose a second disk, machine still runs. Third disk, oops. Okay, so some protection. So those are the most common configurations I see. We'll try and test those. So what sort of workloads do you want to test? Well, workloads, the way that disks performs are just like motor car performance, right? It does depend on what sort of load you put in as to how the car works. And you'd think with a computer, no, it's always going to be constant. But truthfully, it's not. I mean, if you take a performance vehicle, right? So I'm sure you've all got Porsches out there, right? If you fill that Porsche full of all those gold ingots you've got, I know the boot's not very big, but even with a Porsche, fill that full of gold, that Porsche is going to slow down a lot. You take that Porsche and you put it on roads where you can't put your foot down. For those of you who've been to Wales, and you'll go on those so-called A roads and good luck trying to get to 70 miles an hour. I mean, you'll do it once, but you'll just find the last part of the ditch flying off the edge of the road. So you can't always, even if you've got the performance, make it work. And disks are a bit the same. They read differently to the way they write. And when you write, you've got these two types of, you've got this asynchronous write and synchronous write. I'm not going to go into details. It'll bore you all ragged, but basically, sync writes are fast and async writes are slow. You're waiting for the environment to acknowledge that it was written. Okay. So I thought, I'm going to test nice and simple things that you can easily understand. Right? Does everyone get the idea of reading and writing? Okay. Well, this is Wolverhampton. Not everyone locally will, right? But I'm sure that the rest of this educated audience, knows about reading and writing. So I tested a workload that was all about writing. That's really all it did, is just generated stuff and wrote it to disk. I tested a balance workload. So for everything it read, it wrote. So it does one and then does the other. And guess what? I tested a heavy read workload that all it does is read. Now, I did actually test a lot of other things as well, but I think just keeping it to 3 key metrics gets the message nice and simple. If you ever see me in person and you want to give me either a bacon sandwich or a drink, I will tell you about the rest of it and you'll wish you hadn't asked. Okay, so what was it like? What did I do when I tested the heavy write workload? Well, the easiest way of testing to write something is to read it in from a tape and write it onto a disk. I could have written an application, but it probably wouldn't have worked. So I don't program anymore. So I thought I'll let the operating system do it. And the reason why I picked the operating system process, it's efficient, it's tuned, and it is there to make the best use of the storage. And yes, there's a theoretical maximum from the tape drive, but I wasn't worried about that. I was interested in how it could get that consistent offload from my LTO7 onto my disks. So I tested a restore of 4.7 million IFS objects. And I started doing it with the RAID 6 one. And that process, your typical RAID 6 array with its 10 disks, with its single stripe on there for balanced performance, it took 214 minutes. All right. Well, on its own, we don't know if that's good or it's bad, do you? I mean, that's half a DR restore for sure. I did exactly the same disks, but reconfigured them now. Instead of being in RAID 6, I used IBM software mirroring. Okay, some people will call that RAID 1, but there's a subtle difference. Okay, but it's done in software by the operating system. And that reduced it down to 111 minutes. So we can see the fact that we now got disks working in pairs rather than calculating parity stripes, that makes a big difference to the write characteristics. Okay, so well, that's learning, but that's all still with spinning disks. So without moving to NVMe, if I was doing something that was very write intensive, I might want to ask myself, should I be using RAID at this point? RAID 1 rather than RAID 6? Fine. Nothing new there. System architects will tell you that. So what was it like with NVMe? Have we built up enough suspense? 17 minutes, 51 seconds. Let's find out how fast they are. 84 minutes. So it is a lot quicker. Take a look at that graph there. Right? The less is more in this one, ladies and gentlemen, right? So if the bar is shorter, it is better. So you can see at the top there, NVMe shorter than mirroring, shorter than RAID. So in the write workload, we could see that there's a big improvement. So we were looking at 50% difference between the mirroring of IBM hard disks. And remember, these disks are fast. They're generation 3 SAS, 15K. Each of them's got a small bit of cache on them. You know, there's a thumping great big pair of caches in there. So yeah, we had a lot to lead up to in the first place. Right? If you were running on a Power 7 or older, these numbers would be much bigger difference. Then if you compare it to RAID 6, the most typical one, then we're probably looking at close to 3 times, 2.75 difference. So, okay, that's pretty good, because remember, these were fast to start with, right? But there aren't many environments that are 100% right. I mean, we generate a lot of stuff, but usually we read a lot of stuff to writing it. So the balance workload test is probably best. A typical system when you model it is 70% read, 30% write. This is going to be a 50-50, so this is going to be closer to your daily average. So what did I do for this test? Well, I've got those 4.7 million attributes. Oh, sorry, question from the audience.
Two questions in the audience.
Yep.
Heavy write, how many volumes were configured?
How many volumes were configured? So that's the 10 volumes we talked about. Now I could have many more on the NVMe's, but I wanted to keep them consistent. Okay, so 10 volumes were configured.
Follow-up questions, how many much and how much memory was that?
In every single case, for every single test, right, we had, let's go back up one more, one IBM core, 64 gig of RAM dedicated to it. The core is also in dedicated mode if you care, rather than having multiple VPs. Arguably could have been better, but I thought I'm just going to keep it as a dedicated mode. Single core, 64 gig, same LTO drive. The only thing that changed was the storage. 10 physical disks. So if they mirrored, they presented 5 volumes that you could read from in pairs. Exactly the same was done with the NVMe's. So 5 from each one, and we move forward. Any more questions? Just type them into the chat. Steve, thanks for doing that. So questions are welcomed as we go along, guys. Let's make sure I got there. We just got to that point. We were interested in learning more about the balance, the read write. So I've got those 4.7 million objects. So I thought, well, if I read each object and then I write the results to a file. So for every object I read, I write a record into a file, just about its size and characteristics and who owns it. That's a pretty even thing to read. So I'm not reading the entire object. I'm just reading the object header, attributes about it, and writing that out. So I thought I'll do that. Thank you very much to Scott Forsty, who wrote the routine that did that. So I just nicked it. Thank you very much. Again, I wanted something that I knew would work, so I went to an expert and got it. I didn't ask his permission, but Scott's a nice guy. He won't mind me running his commands. So I did that test, and it took 63 minutes on the RAID. Now, remember, the RAID was the slowest last time, the RAID 6 array? The mirroring, it took 82 minutes. Interesting. So sometimes RAID 6 is better than mirroring. Interesting. I was surprised by that one, genuinely, because you think I'll be able to read from either disk. But the thing about that RAID array is it's got that whacking great big cache it can take effect of more effectively. And so it's probably starting to prefetch information, calculate what's going on. So, and if anyone was asking, yes, advanced expert cache was turned on all the way through this because that helps with prefetching, but it wouldn't help one process more than another. So we got 82 minutes. So now between those two types of disk, it's the opposite way around to our first test. Now RAID is better than mirroring. So does that mean that NVMe is going to come last? No, of course it's not. This time NVMe came in at 31 minutes. So again, relative, let's not worry about the number of minutes. It's how relatively quickly are these things going on. So if we compare it to RAID 6, yeah, it's twice as fast. It took half the time. If we compare it to the mirroring, then it's approaching 3 times, 2.75. Interesting, that number came up before, didn't it? But it was with the other storage. But NVMe is still winning. All right, so we can see a benefit there on a balanced workload, which is most like what you're going to use every single day. So let's look at that graph again, and again, less is more. So when we look at that, you can start to see that the relative differences. Numbers sometimes are a bit of a lie, but if you see how big that second line is compared to the NVMe one, you're thinking, okay, I could get my jobs done much faster. Now, interactive ones, if I was to take my interactive workload from half a second and make it into 0.1 of a second, you'd probably notice that. But if it was already at 0.1 of a second and I made it 0.03 of a second, probably not. But how many of us have got workloads that are calculating stuff and we run them in batch? How many of us are starting to put web front ends or consume web services or, God forbid, run Java programs on our IBM I? Right? Those things, we've always made those faster on I by throwing lots and lots of RAM at it, particularly Java. But actually, what Java needs is fast I/O from soup to nuts. So yes, please put lots of RAM in it. IBM I is wonderful because of single level storage. You put that RAM in there, that main storage, and it'll treat it like almost like a level 4 cache. It'll hold the stuff up there. But you know, you can't hold everything. Well, not unless you've got a lot of money. So what's the best way of doing it? You want the fast I/O storage underneath. This will help that workload tremendously. So balanced reading and writing. NVMe also came out on top by a good margin. So now reading, okay? Heavy read. The best workload I could come up with, again, I wasn't going to write anything, was looking at the ARE, damaged object detector. Now, a quick pitch for ARE, the Administration Runtime Expert. It's a free license program that IBM I gives you. It started its life in IBM Rochester's labs as a way of diagnosing problems, gathering lots of information, and giving it to the lab consistently so they could solve your problem remotely more easily. One of the things that they've created, and it's on every single IBM I that's 6.1 or newer, this tool is there even if you don't realize it, is a tool that looks for damaged objects on your system, regardless of whether they are. Doesn't matter which file system they're in, whether it's in libraries or the IFS, what variation. If you could see it in that work link command, which includes the QSys and the QDLS, this will touch it. So it literally reads every object on the system, and it's only interested in one thing, is it damaged? It doesn't do anything with it, doesn't write the information out. It says, are you all right, son? Yep, okay, and moves on. So that runs incredibly fast. One of the downsides of it, if you ever try and run it on your machines, please run it in batch, because if you run it interactively without governing it down, it creates a tremendous batch disk workload. Perfect for what I want. Yeah, be warned, you might get a bit more than you bargain if you run it at the busiest time of your day. So this tool, when I run it, is going to read every object, whether it's in a library, IFS, and it's going to check if it's okay, but do nothing else. So that's perfect for testing a heavy read environment. So what happened? I ran the RAID 6 one, 67 minutes to read my 1.4 terabyte system, which theoretically is 1 terabyte full. This will actually check even the shadow parts because it finds things a little like a reclaimed storages that are orphaned. So I actually can be reading a little bit more than that terabyte, fine. And 67 minutes, how does that compare? Well, IBM iMirroring, again, second place this time. Again, that cache must be helping me. 82 minutes to read it. So NVMe, will it be that 2.7 times faster that we found for mixed read write for intensive write, or will it be slower? Is it going to be, sadly, going to be the third one on the list? Well, 6 minutes. Quantum leap. This is where NVMe and indeed its predecessors, the SSDs of this world, they always were better at reading. Reading is generally a faster thing to do than writing because you don't have to change the state of something, you only have to observe the state. And this is where you see that potential maximum bus architecture. We thought it could be up to 1,500 of whatever those magic units were, right? We're really starting to ramp up there. So 6 minutes. So now we're at, what's that, 11 times faster than the RAID 6. Could be 13 times, not going to try and do the maths on top of my head, from the IBM iMirroring. That's stunningly bloody fast. So if you've got a lot of reading going on, those processes are going to go through the roof. They're going to be a lot faster, regardless of how efficient your code is, or whether it's been reading Java, whether it's reading from a web service. Everything that causes I/O is going to be faster on the reading side. So actually, those numbers that I looked at before, and just check it in the graph, just try and get a relative feel for how much faster NVMe is at reading than spinning disk. I mean, it's stunningly different, right? So those theoretical, so I thought I might be 5 times faster here or 3.5 times faster there, you could actually find it's way, way quicker than that. It might be as little as that 2.75, okay? But that still yields you like a 25% improvement in your workload. But it could actually be that you're actually going to get a 1,100, 1,200% increase in efficiency if you've got a lot of reading going on there. And let's take the middle ground. Even if I told you I could make your workload 5 times faster, that'd be great, wouldn't it? But what did I learn? Okay, let's just summarize it. In the heavy writes, I learned that the NVMe's could be 61% faster than RAID 6. In the balanced one, I found this could be 62% faster than the mirror, but yeehaw, when you get to that point where you're comparing the read speeds, it's stunningly fast. NVMe wins every time. The other storages, depending on what you were doing, you wanted RAID 1 in one case, RAID 6 in another, and heaven knows, I did actually start doing some tests on RAID 5 and RAID 10 as well. They throw in yet more characteristics about whether you want async or synchronous writes, and that's fine. NVMe always won. That's the message I want for you. So we better move on to the cost arguments. In the summary, I told you it's going to be cheaper, but that's not what you would expect, is it? I mean, normally when something's better, people charge more for it. Has IBM lost their ever-loving mind? Well, no, the truth is that IBM doesn't want you to use spinning disks. Not because they can charge more or charge less. The world is moving away from them. It's harder for IBM to find a manufacturer that says, for the next 10 years, I'll guarantee to make you that disk. It's hard to find them to guarantee it will make it for 3. But IBM has to have those long-term commitments to say, look, I'm not only going to prevent you with this system now. Remember, some people keep these systems for 5 and 6 years. They need to have spare parts that go to that 5 and 6 years and beyond. because as the first person gets rid of their system, there's always someone else who seems to buy it afterwards. There's quite a market for these things. We are the Audi of cars, the Volkswagen Group. Yeah, it's not just one owner for a Volkswagen Group car these days. There's always going to be a chain of them down the line. So cost-wise, I promised you a cost saving. Right? This is just to get my friend Mr. Tinker excited. It's not often he gets to see a system config actually up. So I know he's looking at that and thinking, oh, I wouldn't have done it that way, Steve. I could have done it better. Don't worry about reading the system configuration. That is typically what a P05 server looks like. If you want to read it, you can. What I've included this in for is to show that the total cost of the hardware element. In there is the cost for a network adapter, for the tape adapter, for the power supplies, for the power cables. Yes, IBM charges for the power cables, but and ultimately you get to an RRP price for this 64 gig single core. Actually, it's got 4 cores. We're only licensing 1 IBM I system with a tape adapter of 25,600. This is the list price. Your friendly local business partner, I'm sure, will give you a massive discount on there. IBM will have a special offer. I'm just comparing list price with list price so you can see the saving. IBM offers the same or more discounts on NVMe as they do for spinning disks. So if it's £25,000 for a P05 box with spinning disks, what we've been buying for a generation or more now, what's the NVMe? Well, the configuration looks pretty similar, but the RRP is now £18,000, right? So before 25, now 18, 7 grand has disappeared. Now, I know that Mr. Tinker knows the answer. I won't put him on the spot, but when I say the storage is cheaper, right, I wanted to show you in this graph, the pie chart at the top shows the total, the whole circle is how much the hardware server costs, okay? And the blue element of it, to make sure I've got that the right way around, right, is how much the storage element makes up of the whole, right? So if that server on the left-hand side there with its 10 spinning disks, if it costs 25,600 of my English pounds, 13 grand of that, so 51% of the total cost is the storage element. That's not just the disks. SAS adapters, they're expensive. The back plane that can house 18 disks, and on a P05 I'm only allowed to use 10 of them, to get the right number. Right? I have to pay for all those slots. They cost money. When you move to an NVMe, you don't need a cache controller. We'll come back to that later, because surely, you know, hardware and RAID adapters has got to be better. It's got to be better if you do it in hardware rather than software. Well, we'll come back to that. On that NVMe element, it's 18,000 because the storage element has shrunk down by £7,000. The rest of the hardware, the server, costs exactly the same. You know, you're still paying for those power cables, ladies and gentlemen. There's no two ways about it. You can't take them out of the configuration. But what do you care? The overall cost has gone down. Let's take a look at a P10 now. And this P10 I've spec'd up. I've put an expansion drawer on it so that I can have 24 disks outside and 18 disks inside. Still just got the 64 gig of RAM. I know you would normally buy more than that, but I wanted to keep the rest of it the same. It's still got the tape adapter and the network adapter. I didn't go for multiple network adapters. It's just, again, I want to keep just the storage element on there. So now I'm looking at £86,000 because I've bought 42 disks. I've now bought 4 SAS adapters. I've got the standard 2 in the system unit, and I've got 2 more high-speed ones that are driving the extra 24. And yes, for those hardware experts at home, I know that the internal 2 could drive the 24 as well, but it wouldn't drive them fast. The whole point is I want fast storage or I wouldn't have bought it. Okay, so that's £86,000 list price for that. That gets me system unit, 18 disks, 2U expansion, another 24 disks in there. Let's do the same with NVMe. Cost is 46,000, right? 86, 46. Why is that? So again, let's look at the pie charts. The overall cost, when you've got the 42 disks, you're spending 64 grand of your 86,000 on storage components. If you think the disks are expensive, then try putting an expansion on and paying for those. If you think the internal disk controllers are expensive, buy the external high-speed SAS ones. Wow, you're really going to see some pain then. They're very good and they're very fast, but they're not as fast as NVMe. And when you don't need them, in this configuration, I switch to 4 of the 6.4 terabyte NVMe's, and I'm going to mirror those 2 pairs. If I'm using RAID 6 on my 42, I'm going to end up with about 10 terabytes of usable space. So, hey, bonus, right? I actually end up with more usable space for less money, a lot less money, approaching half the cost by switching to NVMe. So it's twice to 12 times as fast and half the cost. Yeah, it's a really hard sell, this one. I can't see why anyone's getting excited about NVMe. And as an added bonus, my running costs go down as well. Right? IBM charges its hardware maintenance by the enclosure. So when I'm using that external disk enclosure, I've got to pay list price £2,800 for whether I've got 1 disk in there or 24 disks in there. If I put SSDs in there, I've got even more. Steve, have you got a question at that point?
Yeah, we do have some questions. Yeah. So from Eddie,
Yeah.
Are they internal only, or can they also be added to a SAN?
Good point. So NVMe is available in a SAN, or it's available on the internal storage. Now, Eddie, I actually did do some monitoring of how fast NVMe is in a SAN, and also SSD and NVMe. That becomes a very complicated question because the SAN has got its own engine size as well. Be very happy to talk to anyone who's of a technical nature about the pros and cons of that. But to answer the question in a way that I think would be the most useful, yes, you can put NVMe in a SAN, and yes, it costs less than buying an SSD, and it should be faster than an SSD would be in a SAN.
Great. Can we have 2 more as well?
Yeah.
There's a question. Hi, Steve. Can the NVMe be configured alongside the current HDD configuration on a system?
Not in a P05 box. There's an option in the P10s above where you could have 6 in a backplane and then the NVMe adapters. Wouldn't recommend that one, but it is possible. That's more for our AIX brethren. It would be perfectly reasonable to actually have NVMe's in the system unit and also the storage adapters that gave you the externals, and have them in different ASPs running different workloads, tiering your architecture. But it's that much cheaper, I wouldn't bother, because if you just want the spare storage, right, normally people I'll buy the HDDs because they're cheaper and I'll put my less valuable storage on it. Well, they're more expensive. So you're actually making the thing that's less valuable cost you more. Any more from that?
Yeah, one follow-up as well. This is from Liz. This was a question I had as well. What about the hardware support costs?
Right.
So how do they compare between hard
So
disks and
SSDs used to come at a premium for support. You'd pay extra for the SSDs. You don't for the NVMe's. I won't say that an NVMe will last as long as a hard disk would do, but that of course depends. If you're only ever going to write to the NVMe once and read from it for the rest of its life, it probably will last longer than a hard disk. But as you write to any sort of flash storage, it is destructive to the process. Now that sounds like a terrible thing, but these NVMe's have been engineered to last a lot longer. They've got this this measure of how many, if I was to write the entire length of the disk, the NVMe storage 3 times a day, how many years would it last? Yeah, longer than I'm going to be in the industry. It's not something I'd worry about. But if you care, they've also created a fuel gauge. So you can run a command and it will tell you the exact health of your NVMe at that point in time. Try getting that out of a hard disk. I'm smiling at my engineer friend in the corner. He's going, yeah, I'm the disk whisperer. I just listen to them. And if they sound a bit cranky, then the chances are then they're going to go. There's anyone's bored, just Google yelling at my disk array. You can actually slow down a hard disk array by yelling at it. They are that sensitive because they're spinning disks to vibrations. Right? So NVMe does away with that. You can yell at your NVMe's all you want and it won't slow them down. No more questions?
No more questions.
Brilliant. Okay.
6 minutes to go.
Thank you very much. So if we look at the cost savings on typical configurations, then you're looking at the 30% saving on a P05 bog standard, 46 on a P10. That is just the server hardware. I have not included any IBM i hardware in there because any IBM i software in there. Sorry, people in the labs, didn't mean to use the swear word when I called your wonderful operating system hardware. Because you could buy one element of that and it has a massive effect on the price. So I just want you to see that like-for-like comparison. Now, if you're wondering what is NVMe and you want some technical details, there's a slide. Allow me to summarize for you. They're bloody well faster. That's the difference. That's what all of that tells you in there, and it gives you good reasons as to why they are. Let me break it out into some simple reasons why it's quicker. And this, Eddie, is why you might not want to put NVMe in a SAN. If you've already got a SAN architecture, it'll make that architecture faster. But if you're just having pure NVMe in it, this might be not the case, because those NVMe's are accessed via a SAS bus. Optimized in a very optimized environment with a huge bloody cache in front of it. But the whole idea of getting away from SAS, and SAS was just the follow on from SCSI, the first S in both of those is to do with serialization, right? We have to access everything in one order. They have multiple lanes, but you can't get stuff in parallel. And when we moved to NVMe, we're now accessing it via the PCI bus, the thing where you'd normally plug the adapter cards in. That is by definition parallel access with more lanes and a much higher speed. That's why the theoretical maximum has jumped up an order of magnitude. So the other big benefit is you've stopped paying for those expensive disk controllers. Now, for a while now, in the standard ones, we've not had to change cache batteries. But if you're buying the truly optimized ones, right, you still have to pay for cache batteries, and you still have to maintain them and swap them every 3 years. What happens if you don't swap a cache battery, Paul? Exactly right. So for those of you not in the room, it goes very, very slow. And when you swap the batteries, there's a period where it goes slow, so you have to time that. It can send a rather terrifying message to everybody if you don't change the defaults, saying that there's been a hardware failure. It's catastrophic when there isn't. Anyway, more on that later. More storage in physically less space. That's the other thing, right? So if you're paying for stuff that's being hosted by the U, you don't need the expansions anymore. You don't need so many expansions, right? There is less to go wrong because there's no moving parts, literally no moving parts, right? We try and get all the moving parts out of a system, right? And because they use less electrical power, because they're not driving these things to spin at 15,000 RPM, then you haven't got a big cooling cost. Yes, Paul?
What's the maximum storage you can get into just internal disk? Because that's always been the Achilles heel of the P05 boxes.
Yeah. So the question from the audience was, what's the maximum you can get in the way of NVMe's? So in the P05s, they've deliberately limited it to just 2 adapters, and they do a 3.2 terabyte and a 1.6 terabyte. That's on the entry ones, okay? So that means the maximum usable storage would be 3.2 terabytes after you've mirrored it, and you would, to get good performance, because I know you know this stuff, you'd put those into 200 gigabyte virtual disks, and they present, so you'd have 16 mirrored volumes, so they show us 32 in pairs as 200, and they'd be super high speed. Now, if you move across to the P10 and higher, then you can use the 6.4 terabyte NVMe's. And it won't be long until we see like a 12 terabyte one or whatever. It's not difficult to pack more in. So you've got those 3 options there, and you can have more of those. I think it's 6 adapters in the largest of the scale-out servers, and a lot more if you go into the larger systems. I've got some slides at the end which will have those details in, and you can start to work that out. And of course, you can still put NVMe in via a SAN adaptive connection, but that's a different story for a different day. I'm not trying to diss on SANs. I'm trying to focus at the low end and save you guys some money. Okay, so what do NVMe's look like? Well, the most common one that you're going to use now is the U.2. It fits in the front of the machine. It looks like a disk, but it's connecting to the PCI bus, right? But you can get add-in cards, right, that literally plug into the PCI bus, and that will be another NVMe. Those are slightly faster. But I mean, this is like saying, oh, you know, there's a slightly faster version of the Bugatti Veyron now. If it gets to the point where you're thinking, yeah, you're not going to notice it. Maybe some workloads would. Any more questions at that point? Yep.
Yeah, one more here from Sargam. He asks, or she asks, is there any defined life cycle for NVMe storage like there is for SSD?
Yes, it's those number of writes per day. And there is a small slide at the end of this, which I'm not going to try and quote, because by the time you read IBM speak about it, it reads 3 different ways. The thing I want you to understand, they'll last longer than an SSD would, but not as long as a flash module would. There is still one level of storage which is probably better than an NVMe, but it's not available inside your machine. Okay. Any more questions there? I'm literally at my time. Oh, sorry, there's a question.
On that one.
Yeah.
if IBM on an SSD charge you extra maintenance because they know it wears out.
Yeah.
They don't on NVMe.
No, not to my knowledge. There's no plans to do that at the moment. There is a defined life of it, and so I don't. When it gets to the end of that, I don't think they'd replace it for free. But that life is so far out, I'm not seeing that on the system configuration. I got asked a couple of questions. Do you mind if I go over by a minute?
You can.
Okay. Yeah. Anyone complaining at home, you can leave. It's lunch next, so literally knock yourself out. Okay. But indulge me for one more minute. I often get asked, so software mirroring. You're talking about using software mirroring, not hardware mirroring. So software mirroring is always bad, isn't it? We've been taught that for a generation now. Things are always faster when you do them in hardware. Software mirroring is actually less efficient. It's not necessarily bad. So it's less efficient to mirror in software. And in this case, we're asking IBM to do that. But these disks are so bloody fast that inefficiency is absolutely trounced by how quickly it gets the data. So the net result is it's faster, even though it's less efficient. Well, one might argue the RISC processor versus the CISC processor. Maybe you heard that before. I've heard you can't hot swap these NVMe's, so when they fail, you've got to take your machine down. That add-in card I showed you, yeah, okay. When you're going to maintain that one, unless you're on an enterprise machine, you're going to have some downtime. If it's the plug-in U.2s in the front, nope, they're hot swappable. But hang on, you said that might be 16 disks. So I'm going to lose 16 disks if I take one of those units out and hot swap it. Surely that's going to fail my machine. No, because it's the 16 disks on one side of a pair. The other 16 disks got the other copy, right? They will be there. You can actually have odd numbers of NVMe's and have different mirror sets across them. That just makes it way more complicated when you're swapping them out. Do it if you want to, but keep them in pairs if you want my advice. So there is no downtime. Even though you might lose 16 of your 32 disks in our basic machine, it's the right 16. You just swap that, take an option, and it rebuilds it. And I heard they wear out. Well, we've touched on this one already, the fuel gauge. So listen, guys, if you want to know more, I left a couple of tech spec slides in the end. I'm not going to read through these because heaven knows I'd be asleep, right? But they give you details of both the U.2 and the enterprise add-in card. Right? It shows you what they look like, and it shows you what recommended storage is. Those last few slides, thank you very much, Douglas Gibbs, for letting me share those. Those are official IBM slides. You can guarantee those to be true. Okay, one last plug. If you like this sort of thing and you like podcasts, please Google The Incredible I Show. It's brand new. They've started this year. There's a couple of really enthusiastic guys. They were kind enough to talk to me, but there are 7 other people you can listen to as well. They put out an interview every couple of weeks. It's a really good podcast. And it's not about technology. It's about us, the people who work with IBM. If you know someone interesting who works with IBM, shoot them an email, and either Peg or Tony will gladly talk to you. So with that, I thank you very much.